For this video, we are going to be discussing conditional statements, which is part of objective G.1. So conditional statements are sort of the building blocks for logic, which is all of what G.1 is about. So let's talk about what conditional statements are. A conditional statement is just an if-then statement. Okay, it's just a statement that takes the form if something, then something else. For example, if it is snowing outside, then it is winter. Okay? It's saying that if this part is true, then this part is true. Okay, that's all a conditional statement is. The if part of the if-then of the conditional statement is called the hypothesis. And we're going to represent with the letter P. So up here where it says if it is snowing outside, the it is snowing outside part, that's P. Okay, that's what we call the hypothesis. The then part is called the conclusion, and we represent that with Q. So up here, it is winter. We represent that with a letter Q. All right? So if it is snowing outside, then it is winter. That's a conditional statement. We represent the conditional with this arrow here. Okay? So we're going to be talking in this unit about how to represent things symbolically. And symbolically, the statement if P, then Q is represented by P with an arrow and Q. This is if P, then Q. Down here, here's another example of a conditional. If it is raining, then practice is canceled. The hypothesis, P, is it is raining, and the conclusion, Q, is that practice is canceled. All right, so this is a conditional statement. And there are four other types of statements that we're going to talk about that all have to do with conditionals. So the first one is what we call the converse. So the converse of a conditional statement is made by taking the hypothesis and the conclusion and just switching them. All right, so an example is, if I have the conditional statement, remember that's symbolically P, if P, then Q. So if I take the conditional statement, if a shape has three sides, then it is a triangle. To make the converse, all I do is I take the conclusion and I make it the hypothesis, and I take the hypothesis and I make it the conclusion. So our converse is, if a shape is a triangle, then it has three sides. Okay? And that's represented by if Q, then P. All we do is simply switch the orders. Okay? And one thing you'll notice is that sometimes the conditional can be true and the converse is not true. For example, if I give you the statement, if you earn an 85%, you get a B. Okay? If I want to make the converse of this, I take this part, the conclusion, you get a B, and I say, if you get a B, and then I take my hypothesis and make it my new conclusion, then you earn an 85%. Well, is that true? Can I get a B without getting an 85%? Sure, I could get an 84%, and that's still a B. So this statement is not true, okay? So even if the conditional is true, maybe the converse isn't. We're going to come back to this later. All right, our next type of statement is what we call the inverse. So the inverse of a conditional statement is formed by negating both the hypothesis and the conclusion. And negating simply means canceling out or putting not in front of it. So for example, if my conditional statement is, if a fruit is a strawberry, then it is red, my inverse would just be, if a fruit is not a strawberry, then it is not red. You can see all I did is stick a not in there, and that's all it changes to make it the inverse. And we represent this symbolically by this little swirly line. It's called a tilde. You don't need to know that. What that means is not. Okay, so this says if not P, then not Q. right? And just like the converse, sometimes the conditional can be true and the inverse is not true. For example, if I look here, if a fruit is not a strawberry, then it is not red. Well, can I think of a fruit that is not a strawberry but is red? How about a raspberry? Okay, so that means this is not true. So this is true, this is not true, but sometimes it will be. So the inverse is simply sticking a not in there. Okay, and our third type of statement is the contrapositive. Okay, contrapositive. Contrapositive is the converse of the inverse. So it's made by doing both switching and negating the hypothesis and conclusion. Basically, you're going to do the converse and the inverse together. So the conditional is, if you score above a 90%, you earn an A. Contrapositive is, if you do not earn an A, then you do not score above a 90%. So you both flip them and negate them. So this is not Q, then not P. Okay? And one thing that is important about this is the conditional and the contrapositive are either both true or both false. Okay? Meaning, if your original statement is true, then so is your contrapositive. If your original statement is false, then so is your contrapositive. These two have to go together. Okay? They are what we call logically equivalent. And all logically equivalent means is that if one of them is true, they're both true, and if one of them is false, they're both false. Okay? So conditional and contrapositive are either both true or both false. So you might want to copy down this chart here that kind of explains how the conditional statements are related. Okay, conditional is P then Q, means if P then not Q. Converse is if Q then P. Inverse is if not P then not Q. And the contrapositive is if not Q then not P. All right, so these are the four relationships we need to know right now. All right, so let's take a look at our first practice example. It says, write the converse, the inverse, and the contrapositive of the given statement. If a rectangle has four congruent sides, then it is a square. So what I'd like you to do is pause the video, try and write these three statements out on your own, and then hit play again when you're done, and I'll tell you the answers. All right, so now that you have tried these on your own, let's see if you got the right answers. So to do the converse, we know that all we do is switch our hypothesis and our conclusion. So our hypothesis is right here. Four congruent sides, that's P. And then it is a square, that's Q. So if I want to write my converse, then it is simply, if a rectangle is a square, then it has four congruent sides. You simply switch the congruent sides and the square. Hopefully everybody got that one. The inverse, we know we simply stick a not in here and a not here. So that could be, if a rectangle does not have four congruent sides, then it is not a square. We negate the hypothesis and we negate the conclusion. Finally, to do the contrapositive, we simply do both of those things. If a rectangle is not a square, then it does not have four congruent sides. We take our contrapositive here and we put the not and not in there. Or we simply switch these two things. So hopefully everybody got those correct. All right, our final type of statement that we're going to talk about is what's called a biconditional. And a biconditional statement is the conjunction of a conditional and its converse. So conjunction, what does that mean? Basically means that this is only true if both the conditional and the converse are both true. Remember we talked about how sometimes one is true and one is not. Well, biconditional is if they're both true, and we write it as an if and only if statement. Okay? And instead of writing if and only if, kind of little mathematician cheat that we can do is we could just write if with two F's in it. That means if and only if, just if. All right, so what's an example of this? Well, an example is, here's a conditional. If you score above a 60, you pass the test. Here's its converse, we switch them. If you pass the test, you score above a 60. This is true, and so is this. So we can rewrite this as, You pass the test if and only if you score above a 60. And if we wanted, instead of writing this if and only if, we could have just written in if with two F's. Okay, so that's all a biconditional is. It's an if and only if statement. It's only true if the conditional statement and its converse are both true. And it's written as P if and only if Q. And if and only if is represented by a line with two arrows on it. Okay, so that's all there is to a biconditional. So let's take a look at a practice example. Practice example says, can a biconditional be written for this statement? If so, write it. So you have to decide, can a biconditional be written? That means are both the conditional statement and its converse true? And if so, then write the biconditional. So go ahead and try this one, and then hit play again when you're done. All right, so let's work this out. In order for us to be able to write a biconditional, I have to write the converse of this statement, and that has to be true. So the converse of this statement is, I switch these. I say if two angles are complementary, then they add to 90 degrees. Well, if you think back to 8th grade math, both of these two things are true. Okay, so I can write a biconditional. And that just means I could say, well, two angles add to 90 degrees if and only if they are complementary. Just stick the if and only if in there, and that's how we do it. All right, so now we've talked about our 5 different types of conditional statements. The conditional, the converse, the inverse, the contrapositive, and the biconditional statements. So, your try-it problem for tonight is to write the converse, inverse, contrapositive, and biconditional of this statement, and tell me, is the biconditional true? And the statement for you to write, to do this for, is if a shape has 4 sides, then it is a square.